Hello everyone, I'm Diego from Cloud Academy, and today we are very glad to have with us Austen Collins, CEO of Serverless. He will be talking about the Serverless framework and new features that they're going to add to the framework. Austin, are you there?
I'm here, Diego.
Great. So let's talk about the Serverless framework and what you incredibly created.
Okay, sounds good. Thanks for the intro and thanks for having me here on Cloud Academy. I'm a big Cloud Academy fan. But just to give you my background, everyone who's listening, I'm a full stack engineer, I'm a DevOps engineer, I'm an AWS community hero, and the founder of this wonderful project, the Serverless Framework. And this is an application framework for building applications exclusively on the new event-driven cloud computing services like AWS Lambda and soon Google Cloud Functions, Azure Functions, and IBM OpenWhisk. So I thought I'd just take some time today to go over an overview of the framework, what it's all about, what the value proposition is, and dig into some of the new features in particular. So let's get started. First off, serverless. What does this mean? Everybody's saying this term, and there's a lot of confusion out there, and I always like to start off a talk by trying to provide some clarity here. So serverless, the definition of serverless, it means those servers exist, the developer does not have to think about them. So there are definitely servers within a serverless architecture. The name is about as technically accurate as the cloud is technically accurate, but if you're a developer, this means a lot. This means that you don't have to worry about operations as much, freeing up a lot of your time so that you could focus on doing what you probably like to do more, and that is just delivering logic, delivering solutions, making things, building things, not maintaining things. So that's the definition of serverless. Our company is also called Serverless too. Before serverless was a big thing, we decided to embrace the brand, and we didn't really know how big it was going to turn out to be. So anyway, we're Serverless Inc. We make the serverless framework, and there is a concept out there also called the serverless architecture, and that's what people are talking about whenever they discuss the concept itself. So what's all the fuss about? Why are so many people talking about serverless right now? What is inspiring this serverless movement? You can see from this Google Trends chart, searches for serverless are skyrocketing. I think I took this chart back in September or something, or maybe earlier. So I know that it's probably, since we're closer to 2017, last time I checked, it was way up here. So a lot of people are talking about serverless. Every single big cloud provider is talking about serverless, like Google, Amazon, Azure, IBM, as well as a lot of big enterprise firms. I just got back from reInvent, and on the keynote stage, I don't think there was a big firm, a big enterprise company, or even government agency on the stage with Werner or Andy Jassy who didn't use the term serverless or at least have some Lambda functions in their architectural diagram. So this is a trend that is taking over and taking over fast, and for good reason. So here's why. Serverless it abstracts cloud computing at a higher level than sort of the previous generations of cloud computing products. We've gone from virtual machines to platforms as a service to containers, all offering various levels of abstraction, and now we've arrived at serverless, which is kind of the gold standard for a cloud computing abstraction, I think, at least. It basically is just code. All you have to do is upload your code, and the provider will run it for you. You don't have to worry about anything beyond that. You don't have to worry about maintaining high availability. You don't have to worry about scaling. The provider, the cloud compute provider, handles all that stuff for you. So again, another way to think about it is serverless is just the newer, better platform as a service. And the traits of serverless, the qualities of what we know as serverless today, all came from this new compute service called AWS Lambda. AWS Lambda was created and released in 2014, and it's basically a combination of fantastic ideas. So when I saw this, I said, you know, as a developer, as an engineer, I said, this is the compute service I've always been waiting for, just because it's a combination of these great ideas. So what are these qualities? Number one is microservice-based. When you're uploading an AWS Lambda function, you write some code, just enough code to perform one job, and then you zip that up and you upload that as an AWS Lambda function. And that is an independent unit of deployment, which is inherently a microservice. So when you're building entire applications on AWS Lambda, you're just zipping up your separate jobs and uploading them as these separate Lambda functions, these separate units of deployments, which is inherently a microservice architecture. And the great thing about that is you get to have, when you're running a big production system, all of the components in your application are basically separate and isolated. So when something goes wrong, the blast radius is limited to that microservice, and you can go in there at any time and update or modify a single Lambda function or add new Lambda functions without affecting your system as a whole. And that is a beautifully agile place to be if you're building an application at scale. Next up, the quality that serverless is most closely associated with is zero administration. It's the zero administration nature of AWS Lambda that is the big driver of this term. And basically, when you upload an AWS Lambda function, Amazon worries about scaling it out, worries about keeping it up, and the developer doesn't have to do that. So the AWS Lambda functions will scale to meet any load. All you have to do is tell Amazon to increase your concurrency limit from time to time if you hit that. Furthermore, AWS Lambda is event-driven. This is another very cool quality of serverless, and this is something that I think we've just begun to see. We're just starting to see the beginning of this event-driven trend. But basically, these AWS Lambda functions will respond to lower-level infrastructure events on your Amazon account. So, for example, when something is saved to a database or uploaded to storage like S3, these Lambda functions will automatically listen for specific events on those types of infrastructure services and run in response to anything that happens on them, any state change, basically. You don't have to manage any separate system for handling the listener logic. AWS, of course, handles that for you, which is fantastic. And there's a lot of stuff you could do with Lambda, just thanks to its event-driven nature. Also, another big benefit that people don't talk about as much for AWS Lambda is just easy access to other managed services. Half the value of Lambda, I argue, is just all the great services that Amazon provides that are so easy to work with inside of Lambda. So it's not just compute that you're getting, you're able to use other higher level services from Amazon really easily, like DynamoDB, S3. And we see a lot of people authoring Lambda functions with the serverless framework, and about 80% of them are all using AWS services. So just the fact that you have this great ecosystem of higher level services available to you is really great. And then also pay per execution. This is a very innovative, very efficient pricing model from Amazon. And it basically comes down to if your Lambda function never runs, you won't get charged. And you only get charged when your Lambda function runs and for the duration it runs. So you could upload as many Lambda functions as you want today. And as long as they never run, you'll never receive a single charge, which is great. There's basically no such thing as underutilization with AWS Lambda. You're not incurring those costs, and again, you don't have to worry about operating those things. So probably the way I describe it best, the big benefit of serverless is that it offers the lowest total cost of ownership. And I think if you add up the sum of all these different qualities here, this is really what you get. And if you're trying to justify embracing a serverless architecture or just migrating some jobs over to AWS Lambda to your boss, to your company, to your manager, this is really what you need to tell them, because this is where it's at. You have a compute service that does not take up a lot of time, barely any to operate, and it doesn't incur any cost until it runs. It's microservice based, which really helps you remain agile. And this is what it comes down to, and this is why people are embracing serverless architecture so quickly, both startups and large enterprise firms alike, because they want this specific benefit. They want to be able to do stuff, to deliver features, to deliver software faster than ever without having to worry about maintaining it. So again, since AWS Lambda has been out for a couple years now, other cloud providers have announced or made available their other serverless offerings. So Azure Functions recently became available. It looks fantastic. They're doing a lot of interesting stuff. Google Cloud Functions, also beautiful developer experience. Soon to be coming available, I hope. and IBM OpenWhisk, which embraces serverless from a different perspective, from the entire platform perspective, which is interesting, especially because it's a nice on-premise offering. So a lot of great variety here, and the serverless framework is going to work with all these so that developers have choice in where they deploy their functions, and helps alleviate lock-in. So what excited me from day one when I saw AWS Lambda, and it was really just this idea that it would increase my productivity and potential as a developer. You know, and one way to think about it, we sort of talked about the lowest total cost of ownership benefit, and that's kind of how you justify it to your company a lot of the time. But as a developer, you can think of it this way too, and that is, if you don't have to worry about paying for these functions until they run, and you don't have to worry about operating them, what's happened here is you kind of you flatten the last couple barriers between the developer and being able to just provision more logic, more solutions, more results than ever before. And that's really exciting. It's like a lot of this energy that was previously allocated to operating and maintaining systems is now liberated. And what you get is just well, a huge increase in productivity and potential. And this is what excites me as a developer, because I like building things. I don't like maintaining them as much, if that's not clear already. Anyway, serverless framework. What is this about? So the first thing you'll notice when you actually want to build something large on AWS Lambda, and probably the same for Azure Functions and Google Cloud Functions, is that what you're actually making here is a really large distributed system, and that is hard to manage without help. So I had this realization on day one. I said I wanted to refactor a project to run exclusively on Lambda. I provisioned my first Lambda function via the AWS console. It wasn't that difficult. But then I wanted to, of course, convert this entire application to run on Lambda. And I quickly realized, wow, this is going to take at least 100 Lambda functions. And again, those are 100 separate independent units of deployment. And that is just a lot of small pieces to manage. Furthermore, you have to manage the infrastructure dependencies across all these Lambda functions. For example, these Lambda functions need access to this DynamoDB table. These Lambda functions need access to this S3 bucket. You have to manage permissions across all that stuff, replicate all these functions across different stages or different environments, so that you have a dev and a staging or a test stage and a production stage, of course. And doing all this stuff manually without some tool is very, very challenging. So immediately I realized that this is the perfect problem for a framework to come in and solve, a new type of framework actually, which is what the serverless framework is. So essentially, serverless framework is a command line interface. It's written in Node.js. It's all in JavaScript. We try and keep the JavaScript super simple, easy to read, because it's open source, of course, and we have a lot of people contributing it day to day. But basically, the CLI is designed to manage the lifecycle of your serverless application. That is, it's going to create scaffolding for you. It's going to help you through your first deployment. It's going to help you through rollbacks. It's going to help you test your code. It's going to help you run that code locally, and ultimately remove it whenever you're done. You know, if you're ever done. Again, these functions don't charge you until they run, so it's easy just to provision infinite amounts of logic and let it sit there. But the serverless framework helps you handle this entire life cycle of managing a lot of Lambda functions, essentially, and their resource dependencies. Features of the serverless framework. Again, it's application lifecycle management. That is the big purpose of the framework. Also, the framework manages code and infrastructure. So it's not just a tool that uploads your code to AWS Lambda, but it also provisions infrastructure for you. So it's a bit different than your average framework in that regard. Additionally, it does scaffolding. It will scaffold a whole bunch of different templates for you, different types of serverless architectures, as well as perform a ton of useful automation to do that application lifecycle management. Additionally, another difference in this framework is that it supports multiple languages. So though it's written in Node.js, we seek to support all of the languages that AWS Lambda supports. So that's Node.js, that's Python, that's Java, and any other language that Lambda introduces in the future. So the framework, you could actually deploy stuff in Python, Lambda functions in Python, Lambda functions in Java. And that's very cool. So if you have a team with a variety of experience and preferences as to the languages that they use, they could all use this. and work in the language of their choice. Additionally, multi-provider, this is a big effort for us. Developers should be free to deploy functions everywhere. The idea that you could deploy functions to multiple clouds is really appealing because you're able to take advantage of, again, the higher value services that a lot of these clouds are providing. So a lot of people, for example, want to use Google's machine learning stuff. We're going to help you deploy a serverless function or a Google Cloud function right on Google so that you can do that. Because even if you already have a whole bunch of AWS Lambda functions. So we basically are seeking to provide a uniform experience for deploying functions anywhere. And we have a lot of stuff coming out in this regard. It's going to get pretty exciting to see how people rig up these serverless architectures and across clouds and deploy functions everywhere. Additionally, permission management. This is a huge feature of the framework. Again, a serverless architecture is a massively distributed architecture, and it's both wonderful and a challenge at times, especially from the perspective of permissions. Every single one of these pieces needs to have their permissions managed and kept secure. So the serverless framework practices the principle of least privilege when it comes to permissions. It'll automatically set up permissions for your Lambda functions and the infrastructure that they're interacting with for you, and lock it down so that there aren't excessive permissions between those things. Additionally, Serverless Framework offers a great local development story. So the challenge about Lambda and these new serverless services is that they are cloud-based, and they're hard to emulate locally. Well, this is where the Serverless Framework steps in. It does a lot of local emulation. Some of it is built into the framework. Some of it is offered through plugins. So there's a great serverless offline plugin which will create a local server on your machine and emulate all of API Gateway so that you could just test out your backend locally. It's pretty powerful, run by a few fantastic community members. So this is a big deal. If you really want to build stuff, really want to build large serverless architectures, or just a few Lambda functions, having that local development story is one of the biggest benefits. Additionally, the serverless framework is extensible. So this is a big effort for us. I believe that any developer tool should be extensible. As a developer, I like to hack, I like to change things, I like to modify things. So we made a big effort to make Serverless Framework extensible from day one. Also, the day this went viral and I saw all the issues pile in about all the requests and how people wanted to manage their workflows and stuff, I quickly realized that to meet all of these I quickly realized how subjective workflows are, and to keep up with them, we just needed to make the framework customizable. So it's all basically one big plugin architecture. You can write a plugin to replace functionality of the framework, or you can write a plugin to add new functionality. It's super powerful. Also, Serverless Framework empowers the serverless team. So when you're working in a team with a whole bunch of people who are trying to work on this large distributed architecture, it can get challenging, and the Serverless Framework has a lot of principles built in to help guide you through that. Lastly, there's a fantastic community behind the Serverless Framework. Everybody is super enthusiastic and helpful. Doesn't matter what level of experience you have, you're going to find large enterprise firms in our chat room. Some of them are contributors who are super helpful. You'll find startup people and hobbyists who are in there as well, who are also super helpful. I'd say about half of our users have at least 2 years of Amazon experience. And then 1/4 of our users have less than 2 years, and 1/4 of our users are entirely new to Amazon Web Services. Which brings me to another big point, which I didn't write in here, but is so important. It's developer experience. And this is what it's usually all about when it comes to dev tools. The Serverless Framework provides a fantastic developer experience. We focus on this all day long. And there are so many people who use the framework who've never even used Amazon Web Services before. And I think it's because of the developer experience that we provide. We've done a lot of great work just surfacing the things that really matter on Amazon and handling them all for you behind the scenes. So lots of other great features, but that's a basic overview. So use cases, what can you do with this thing? Our biggest use case are backends for web, mobile, and IoT applications. So this is what we see most people doing with the Serverless Framework right now. And what this looks like for a REST API over here in this diagram is that you'll have a Lambda function which contains your business logic. For example, it saves a user to a database. You could put another Lambda function in front of that, actually, which does all of your authorization logic. A lot of people think this is a big revolution of serverless, just how easy it is to put a Lambda function to do auth in front of all types of other stuff. So you could actually set this up to be in front of a Docker container or something like that, or any other service. But then in front of that, you could put an HTTP endpoint really easily via the framework and Amazon's API Gateway service. And this basically works like this. The request comes in, one Lambda function fires to do auth logic, the second Lambda function then handles the business logic. So this is our biggest use case. Again, the ability to be able to build REST APIs that, a lot of them won't even really charge you until people hit those URLs is pretty powerful. It's pretty efficient. Data processing, Lambda was started as a data processing tool. You could do a lot of this with the framework. It's very easy to to hook up a Kinesis stream or DynamoDB stream to an AWS Lambda function. Also, and probably one of my favorite use cases is just all the internal DevOps automation that we see the framework being used for. This is basically engineers, developers, operators automating their day-to-day tasks away by putting them in Lambda functions. So we see people build their own CI/CD systems with Lambda. We see people doing load security testing Lambda functions. Nordstrom has a great serverless framework-based project out there that actually is a interrogation suite of Lambda functions. So whenever they deploy one Lambda function, they have a suite of other Lambda functions that will respond to that recently deployed Lambda function and hammer it with a whole bunch of different types of tests. It's a very cool tool. Also, you can monitor logs very easily with Lambda and build all types of auditing systems. So this stuff, there's just the sky's the limit with this, and there's a lot of cool stuff coming out every single day. And much more. Chatbots is a big use case for the serverless framework, machine learning, scheduled tasks, designing systems to do processing in parallel with a whole bunch of Lambda functions, working on a job or a part of a job at the same time. And what we've noticed from day one is that this new type of cloud compute service is so efficient and so convenient that it's really bringing all users, that is large enterprise firms and startups and hobbyists, as well as all use cases to the table. And I don't think that there's anything you can't really do. Well, there are a few small things, but most things you could do with AWS Lambda. And for the rest of things that people haven't figured out how to do, trust me, there are people trying to put it in a Lambda function and make it work. So there's so much stuff you could do. It's pretty exciting overall. So getting started, how do we get started with the serverless framework? First off, it's a NPM module. You can install it via NPM, of course. You want to install it with the global flag. And this is going to install the serverless framework globally so that you can access it via NPM. And I have it already installed here, and I could just run serverless. And it's going to show me a nice list of commands. Next up, let's create a service. So what we learned early on is that functions naturally travel in groups. That is, a lot of people will make functions and group them together because they all work as part of a single workflow, or they perform operations on a data model. For example, users CRUD would contain 4 Lambda functions that are all working off of like a user's DynamoDB table, for instance. And we realized that it's easier to manage all these smaller bits if you could kind of put them in larger groups. And this is not a project per se. Whenever you create a large serverless architecture as a single project, it definitely creates blocking issues, especially if you're working in a large team. If you're working by yourself, definitely just create one of these services and use them as a project. But if you're working in a large team, a project is usually going to consist of multiple services, which again are just groups of functions, events, and their resources. So instead of just talking about it, I'll create one real quick. So I'll run serverless create template AWS Node.js, and this is going to create scaffolding for Lambda functions running in Node.js, and I'm going to pass in a path here. Let's just call it REST API. So the serverless framework is going to create some scaffolding for us. I will open it up real quick. And in there are two files, handler.js and serverless.yaml. Let's dig into serverless.yaml real quick and take a look at what's in there. Pretty minimal scaffolding. Just these two files. And again, you can create scaffolding for Lambda functions that run in Java, Lambda functions that run in Python. But this is what you get. So serverless.yaml contains your Lambda functions, their events, anything that triggers a Lambda function, as well as resources. And there's a lot of sort of useful stuff you could use in here. But if I just trim it all out, trim it away, you could see how kind of minimal and simple this actually is under the hood. And again, I could put resources here as well. So this is a pretty clean YAML file. Basic provider defaults, you could put in here. The service, which is again kind of the name of this service or this project, put it up here. And functions is a list of functions and their configuration. So in this, we only have one function. It's called hello, and it's pointing to a handler.js file and the hello module in that handler.js file. And additionally, here at the end, we have resources. So you could put raw CloudFormation in here. You could put a DynamoDB table. You could put an S3 bucket, whatever you want. Again, the point here is to keep your functions and their resource dependencies together in this concept called a service. And again, you can make a whole project in one service, but it's good to know that at some point you could actually break these off into separate services to make them more manageable, and so that different teams could work on those separate services without getting blocked by anybody else. Handler.js contains our actual code. This is just some code in Node.js, but it's pretty straightforward. There's just what's passed in here are the parameters from AWS Lambda, and we're just constructing a basic response and returning it. And this response is designed to use via API gateway, so this is a correct response. You'll need to return a response from an HTTP endpoint on API gateway. Let's see where my presentation went. Okay, next up, we want to add some events to this. So again, right now in serverless.yaml, we have a function, but we don't really have anything that's going to trigger that function. Now, we could manually invoke it with the framework. That's really easy, but we actually want this function to do something in response to an event. So to set that up, all you have to do is add an events property, and we're going to make a simple HTTP. We're going to make a simple REST API, basically. So we're going to add an endpoint to this. We'll put the path as hello. We'll put the method as a get method, and that's it. So events, you could have one or multiple events that trigger this Lambda function. We have a whole bunch of different types of events. You could view our documentation like a S3 bucket upload or a DynamoDB stream, for example. And all you have to do is just put these in the array here. And all these events will automatically trigger your Lambda functions. So next up, deploying this. Basically, we have a Lambda function. We have an event, which is an API gateway endpoint. This is actually going to create some separate API gateway REST API in your Amazon account. Additionally, it's going to create some IAM resources and manage all the permissions for working with these two infrastructure components together. That is the API gateway endpoint and the Lambda function. And all we have to do to deploy this service is run serverless deploy. And I'm not going to add in this stage flag because it's automatically set to dev. So I'm going to run serverless deploy, and it's automatically going to be deployed to a dev stage. So what's happening here is every single service in the serverless framework is a separate CloudFormation stack. In fact, when I run deploy, all that really happens is that this syntax right here gets compiled to a CloudFormation template, an AWS CloudFormation template that really turns out to be hundreds of lines long, because CloudFormation is a very verbose, very mostly lengthy syntax. And So when I deploy this, this is what happens behind the scenes. What we do, of course, is we just create a more simpler, more elegant syntax that speaks to the majority of use cases on top of CloudFormation and compile to it. So when I run serverless deploy, this deploys a separate CloudFormation stack. And again, whenever I deploy this to a separate region, I could run serverless deploy stage, sorry, a separate stage, prod. It's going to create a totally separate CloudFormation stack of my functions and any infrastructure. So while this is going, the first CloudFormation stack deployment takes a lot longer because it's creating the permissions, IAM roles, essentially. And what happens on Amazon's end is that they actually go around and replicate those IAM roles because it's a global service all around their data centers. So this deployment usually takes a bit longer. And that's it. The entire stack has been uploaded. And I'm actually going to switch over to a previously deployed stack here. So I have the same service already deployed. And I'm switching to it because it has a bunch of other stuff in here that I want to review. And I don't want to type it in because it's just going to take too long. So anyway, this is already deployed. Think of it as I just deployed as if I just deployed the other one. And next up, we're running a command called serverless info. So we just want to see the information of our serverless service here. And by running this command, we could see functions. The functions in our service here, and we just had that hello function. The framework automatically adds in the service name, and again, this service name is the REST API backup, as well as the stage name, as well as the function name right here. So we have one function and then an endpoint, of course. And just to prove that all this stuff actually works, I'm going to try out the API endpoint right now. And there you go. That's it. All it took was simply creating a serverless service, adding in an API endpoint event to a single function, and then deploying it. And what we're looking at here is a massively scalable pay-per-execution REST API endpoint. And it doesn't get much cooler than that. So again, anytime I want to see the information on my serverless service, I just run serverless info and it will pull that information into the console. And again, we just test the endpoint. We tested it out through the browser, but we could actually run tests via the framework. This is kind of where the framework really shines. So I'm going to run serverless invoke, and I'm going to add in a function parameter here. And I'm going to put in hello. And this is going to invoke the function on AWS Lambda in my serverless service that's called hello. So this is actually going up to AWS, it invokes the function runs, and this is the response that is returned from the function. It's actually the same response that was returned from our API endpoint over here. There's another sweet trick you could do here. You could add in a logs flag so that if you want to actually invoke the function and get some logs back, just pass in that simple option here, and you'll see it return the response as well as the logs of the function, and it's pretty convenient. Now, to speed up development, we've also created again a local emulation of Lambda, and this is a lot faster. So if I want to go ahead over back to my my serverless service, and I want to go into my code and I want to make a change, and I want to see how it works quickly. All I have to do is modify my code here, and I can run SLS, by the way, is a shorthand syntax for serverless, so you don't have to type serverless out all the time. You could just use SLS. I could run SLS invoke local and pass in the function name, and it's just going to run the function locally. And this is great because the serverless development workflow is actually pretty slow. If you're always trying to deploy stuff to AWS Lambda before you could see it, and the ability to just test this stuff out locally is super powerful. So this is invoke local. I could then, let's do a quick modification to the code here and actually deploy this so that we could see how easy it is to do changes. This function has been updated. Okay, this is the message that it previously returned. And now another thing we do to speed this up is that you don't actually have to run a full CloudFormation deployment every single time. Instead, we give you this other command to deploy a function, which is a lot faster. So you only want to run serverless deploy when you're actually making changes to serverless.yaml, infrastructure changes, because that's what this is in here. This is syntax to describe infrastructure. And when you change this, you should run serverless deploy, which again will update your CloudFormation stack and update the infrastructure in it, which is described here. But if you're changing your code, we have serverless deploy function, which is a lot faster. So let's do serverless deploy function, hello, and that was it. We quickly switched out the code in our function. We updated the response to return, and there we go. This function has been updated. This is our API endpoint. You know, in production in the wild, you can see how quickly and easy it was to switch out that code. So again, run serverless deploy if you're making infrastructure changes. That's going to take a little bit longer because it's processed through CloudFormation. But when you're working on function and you're just working on your business logic, run the serverless deploy function. Additionally, we have a helpful command here called serverless metrics, which you can run to see some basic information about your functions right here in the command line. We like to make it really easy for people to work with their serverless architecture without ever having to go into the serverless the AWS dashboard. So we want you to do everything here in the console because that's kind of the way we think it should be. So serverless metrics returns some basic information about your functions here. You can see that this function has been tested or invoked 14 different times. Haven't been any throttles, haven't been any errors, and I can see the average duration of my function right here. Okay, adding environment variables. This has been a big request for so long. We finally have this functionality added into the framework. It's very powerful, it's very easy, and I'm going to go over it right now. So every single function in here, you can easily add an environment property, an environment object. And this object can have as many keys as I think the Lambda size limit will allow for environment variables. I don't know what that is off the top of my head, but I'm sure you could probably have about 30 of them at least. And you could also provide service-wide defaults by putting stuff in the provider object. So if you want all your functions to have the same environment variables, you could put them here in this one place. But we're not going to do that right now because this is already set up. And I'm going to comment out these real quick. So we're specifying an environment variable. We have foo with the value of bar. And we want to make sure that we log this out so that we could see the environment variable in our code. And actually what I'm going to do is I'm just going to, instead of doing a few separate deployments there, I will just console log all those. Did I take it out of serverless.yaml? No. Function hello. Okay, so I just deployed a new copy of the function. I'm going to invoke the function now, and I'm also going to return the logs here. So what's happened? So we have 3 console log statements, all returning the environment variables that I've set in the environment property for my Lambda function. You can see it's returning foo, foo2, foo3, and when I invoke it on Lambda, of course I get the response, and here are the logs here, and the environment variables are right in here. So there are a few ways you can set these. You can just add in the value right here. But additionally, we have something called serverless variables, which is really handy syntax for referencing values from other sources. And in this example, we're using our serverless variables syntax. And you could reference a different file, which is what this is doing, as well as a property in that file. You could reference command line options that are passed in. You could reference environment variables on your system already too. So there's a bunch of powerful stuff that you could do here. And so in this example, I'm just referencing an env.yaml file, which is in my serverless service root folder here. And you can see that in here is just a simple YAML object of foo2 and bar. So I'm referencing that file, I'm referencing the foo2 property, and before this is deployed, this variable is filled in with its reference, which again is just bar. And another cool thing you could do with serverless variables is you could reference JavaScript files. And this is pretty neat if you need to create, dynamic variables, different variables, or even fetch variables from a remote source. So in this example, I have a env.js file that I'm referencing and a foo3 module in that env.js file. And if I open up env.js, you'll see foo3 here, and this is returning bar, of course. So what's happening here is whenever I do anything with the framework, this variable actually goes and runs that code in that file and fetches the value from that code. And again, these are all returning bar, but a lot of cool things you could do here for environment variables. And I could easily write some code in here that just goes and fetches variables or secrets from some secrets as a service provider, and then returns them right here, just right before deployment. So super powerful, and again, you can move this environment property up to provider to set the same environment variables for all your functions. Okay, now what? I mean, that was the serverless framework in a nutshell. You have your basic commands here for deploying and invoking your functions. There is a serverless rollback support, and we actually roll back at the CloudFormation stack level, so it's very easy to pick a previous deployment and roll back exactly to that. So if I do serverless deploy list, I'm going to see all the deployments I've made, as well as their timestamp, and this is what you will use whenever you type in serverless rollback. You'll add in your timestamp there, and the serverless framework will roll back your entire service to that specific CloudFormation template and code. So that's very handy. In addition, we have a serverless remove command, which if you run this, it's just going to clean up everything, remove everything that we just created from your AWS account. So that at a high level is the serverless framework, and that's how you do basic application lifecycle management with the serverless framework. In addition to that, there are tons of plugins, tons of other features. Check out our docs, of course, for more things you could do with the framework. And here they are. So serverless.com/framework/docs. We spend a lot of time on our docs, and there's a great search feature which you could use to easily find something in the docs. We have a great examples repository filled with a ton of stuff you could do, basically pre-made serverless services that you can install quickly, and you can either reference or install and deploy them immediately. Also, we have a forum.serverless.com, and a chat room. It's just chat.serverless.com. There's a ton of helpful people in there. Again, enthusiastic, positive, supportive people who want to help you get started, even if you have no experience with Amazon Web Services. So check these out. And a few tips on just how to go serverless. What we see, when you want to bring this technology into your organization, into your company. It all starts with one person who has seen the framework, understands AWS Lambda, and they go into their workplace and they start looking at jobs and tasks, and they start asking, can I put this in a Lambda function, or will it Lambda? And they run a few experiments, with the framework, and it works most of the time. Yeah, it works. You'd be surprised what you could put into Lambda functions. And again, once you migrate stuff over to Lambda, you don't have to operate it anymore. You don't have to pay until it runs. So that's usually the first step, and then after that, people take notice in the organization, and the serverless team is born. We've seen this at many large companies. They all had one person go in and start doing some serverless experiments, And soon after that, the serverless team was born. We have large companies running tons of Lambda functions now, doing hundreds of millions of invocations every single day, and they have serverless teams of 5 to 10 people now, and these serverless teams are super productive, and yeah, they get a lot of stuff done. And also, when you're thinking about migrations, like how do you migrate stuff over to AWS Lambda to a serverless architecture, just remember that this is inherently a microservice architecture. You don't have to go migrate an entire application. All you have to do is migrate a single job. Start with that and incrementally move stuff over and put it in a serverless architecture. So, and most importantly, use a good framework to move fast. Serverless architectures are all about moving fast. Doing stuff quickly via microservices, continuous deployment, and a lot of local autonomy. And you're going to need a good framework to help guide you and make sure that you do all that safely. We are that framework. And that's basically it. Here's my information. I'm going to go answer some questions real quick if there are any. But check out serverless.com for more information. Here's our Twitter handles. And if you're interested, if you have a company organization that wants to learn more about this, we do workshops and seminars. Just contact Nick over at nick@serverless.com. So I'm going through my questions here. I don't think anyone else can see this. Okay, number one question. Is this a vendor-specific tool? I have about 15 minutes here, so if anyone has a question, feel free to ask. I'll go right through these. Someone asked, is this a vendor-specific tool we would have to buy or standard AWS commands? This is an open source tool. We make no money off this. We don't even have a single commercial product at this time. We are venture-backed by the investors behind Docker, actually. So we've got a lot of money in the bank, we've got a lot of resources, and we're going to be working on this open source tool for a long time, and we're slowly going to bring in some commercial products, but the serverless framework will always be free and open source. Now, you will be charged for any AWS usage that you use, and there's nothing that we could do about that. Sorry. Next question. How can we calculate a previous ballpark number representing the cost of the Lambda serverless service? How can we calculate a previous ballpark number representing the cost of the Lambda serverless service? To do cost calculations, a previous ballpark number. There is a serverless calculator online that you can use. I think that there are now a ton of resources on the internet you could use to kind of estimate Lambda costs. I mean, it's not that complicated. You just look at the memory size of your Lambda functions. You run some tests and look at the average duration of your code. Again, use serverless metrics to help you through that. So this will give you some basic information. Whoops, serverless metrics. Hello. And you could look at this duration, and we're going to put some cost information in here too, by the way. So this will be another resource. But it's pretty easy to do those calculations, and you have all the information you really need right here. And again, we'll add in cost to this stuff very shortly. Question number 3, does deploying the Lambda via CloudFormation give you the ability to do red-green deployments of new versions of Lambda? Yes, there are a few ways you could do this. Basically, you'd create separate CloudFormation stacks and then take your API gateway and put that in a different CloudFormation stack, and then use that API gateway to point to one Lambda function or the other. You saw how easy it is to provision Lambda functions to different stages. Again, these are totally separate independent units of deployment. But then you could have that API gateway point to any Lambda function you want, and it's very easy to switch that back and forth. We have some tooling, in fact, that's coming out that's going to help automate this and do it all with best practices in mind. So please be on the lookout for that. Number 4, is there a way to monitor, profile, debug those functions? There is a way now. Amazon has just introduced AWS X-Ray, which is a distributing tracing service / APM service for serverless for anything that runs in EC2 essentially, but especially for serverless architectures. And the best part is all you really have to do is turn it on. But it will actually trace through your Lambda function, and any DynamoDB requests or S3 requests that it makes, and give you a ton of performance information about each step of that trace. And that's a new service. Definitely check it out. Otherwise, what most people do is they'll just make some simple CloudWatch dashboards and rig up their own monitoring, profiling, debugging tools. But check out X-Ray. It's really going to be a game changer. It's filling in the missing piece of the serverless architecture, which is just like, how do I understand performance across all these distributed components? How do I do root cause analysis? How do I do performance, correlations, all that stuff. Number 5, when you invoke locally, what happens to your attached resources? DynamoDB. Sorry, my chat box keeps going up and down. What happens to your attached resources? So when you invoke locally, you're still going to work with the resources that are deployed. So we can't emulate every single AWS service locally. That is a daunting task. But since all these services are just in the cloud and you can access all of them via REST API, or a lot of them, like DynamoDB, when you run a function locally, it will just make a request to DynamoDB. It'll go a bit slower, but it still works. So that stuff is all available. Same with S3. You could make a request to S3 from your local invocation, and that will all work for you. Number 6, is there a cost for this serverless framework? No, I wish there was. We've been working on this for a year and a half, but there's no cost. It's all for free. It's all open source, and it will always be that way. So check it out, jump in, contribute, or just provide feedback and use it for free and be happy. Number 7, any plans to have a Slack channel for developers to collaborate? Yes, we have a Gitter channel with over 2,000 people in it. We've actually got to go divide it up into different rooms now because it's just too crowded in there. But there's people in there every single second of the day ready to help you. So check it out, chat.serverless.com. 8, is there a marketplace for serverless services? No, but that's a great idea, and there should be. There are, on our GitHub repo, there are a whole bunch of example serverless services. You can actually install them by just running serverless install, and then just add in the GitHub URL right here. And the serverless framework will go download the repo locally and set it up for you. So check out the serverless framework repository in GitHub. There's a whole bunch of services doing all types of cool stuff that are basically ready for you to deploy right now. As for a marketplace, Amazon is doing some interesting stuff in this direction. They're now allowing you to monetize API gateway endpoints via their marketplace, and you can have anything on the other end of that API gateway endpoint, but I think Lambda functions will most likely be at the other end of that. So, and that is entering an interesting and new world for SaaS. And anyway, so look out for that. Number 9, how to make API Gateway private, or do you think AWS will add VPC support to API Gateway? API Gateway private. I'm just going to say just be on the lookout for something like this. Who knows? I know that Amazon is very aware of this. Running VPC support for API Gateway in particular. So, I would talk to them about it, ask them what they're up to there, and if they plan on doing this, and when it might come. How to make API Gateway private. So what you can do is just put a Lambda function, basically a custom authorizer, and the framework allows you to do this really easily. And I showed you in the example, if you go back to the earlier parts of my presentation, the use cases, I showed you how to make a diagram of a REST API, which actually featured 2 Lambda functions. You can have a Lambda function that does auth, and in that Lambda function you could use Cognito, you could use auth0, and you could even put make API keys mandatory on the endpoints themselves via API Gateway, and there's config settings for that in here too. And you should be able to do it right here in the HTTP event. So check out our documentation. You could set API keys right here on HTTP, or you could set an authorizer which will do auth logic in a separate Lambda function that fires before the Lambda function with your business logic. And in that Lambda function, you could use any auth implementation you want or service that you want, Cognito, auth0, JSON Web Tokens, whatever you need. Okay, 10, can we pass arguments to the env.js function, for instance, the deployment stage? No, not yet, but this is changing very, very soon here. So that's absolutely coming. Just wait like probably like a week or two. There's a lot of cool stuff coming with that functionality. Or you can submit the PR yourself, which is I think about 50% of our PRs now come from the community. So we take those very seriously. We're monitoring this full time. We've got tons of people working on the framework now. 11, can you add a comment or description when a deployment to better identify it when you list your deployments? By time step alone, might not be descriptive enough. No, but we've been chatting about this, and this functionality is coming soon. So that's happening very soon. It's just about how well AWS supports that. I'm not sure. I'm sure CloudFormation has something for that. So that's coming soon. We've been talking about it. Number 12, aside from DSL simplicity, what does this offer over Terraform besides CLI-based statistics? Terraform is a fantastic tool. It's very, very interesting. What we do is that we don't try and cover the entire cloud provider and all their resources and all of that. We are very biased towards serverless architectures. And I'd argue that gives you a lot of great functionality, a better developer experience, and safer deployments for doing serverless stuff out of the box. So the whole framework, everything is just biased towards doing serverless stuff. And when you approach it from that perspective, you get a lot of safety in deployments. You get a lot of functionality just around doing stuff with your serverless architecture. And you get a really great developer experience that is just focused on helping you do serverless stuff faster. So we are biased towards serverless things. Number 13, is there serverless infrastructure for on-premise installations not on public cloud? Number 13, not yet. Just await a little bit here. We will have some compelling stuff to show you very, very soon. Additionally, we have an IBM. I know that Azure Functions, I believe you could run on-prem, and IBM OpenWhisk you could run on-prem, and we're working with the IBM OpenWhisk team and the Azure Functions team, both wonderful teams, on integrations. You can actually go see those being worked on in real time in our GitHub repository. So you can go in there, chime in, and see if some of those on-premise offerings will work for you. Again, we have some more stuff coming here so that people can deploy functions everywhere, again, via the same uniform experience. Number 14, how do you think Lambda, functions as a service, serverless, impacts the legacy security model going forward? Traditional security vendors focus on devices scanning content in the middle to protect legacy architectures like web services. Web servers. Will this push them to move to a more API-focused model, in your opinion, or what thoughts do you have around how security changes? The great answer is that a lot more security is handled by Amazon, which is kind of what you want because they have more resources to put behind security than probably a lot of companies out there, probably the majority of companies. So that's fantastic. Again, as developers and companies and teams, it's great to be able to offload a lot of that stuff as long as you could trust the party offering it. Additionally, one thing I will say that's kind of been raised as a concern, but also handled already, is just when you have all these separate units of deployment and you're producing more code, you're provisioning more code, a lot of this code is using more open source dependencies, and you want to be careful about what types of open source dependencies you're putting in your code. And there is a serverless plugin for this actually, which integrates with the SNCC service. So that when you run serverless deploy, if you have this plugin installed to your serverless service, and again, you just install plugins by putting them right here, and then you could just, serverless plugin 1. And all of a sudden you've added functionality to the framework specific to this service. So SNCC has a service that scans open source modules for vulnerabilities, and if you have their plugin installed, every time you run serverless deploy, it'll do a quick scan of all the modules, all the open source modules that you're deploying, and warn you if there's anything wrong with them. Super powerful, very, very cool, highly recommend it. Number 15, are you going to support step functions? Any estimate on when that could happen? Absolutely, step functions is super cool functionality. We're working on it. I was hoping to talk about it on this webinar, but it just came out. We didn't want to rush it, but it's in progress. 16, is there a feature in the serverless framework or community tool that allows you to orchestrate the execution of your Lambda functions similar to Amazon step functions? Step functions is kind of the only way to do this right now. However, you can orchestrate sort of custom workflows via custom CloudWatch events. I know this is possible, and you can recreate a step functions experience. It'll be a bit different in terms of what it offers, but you can do that way. Additionally, I would just say that that you should sign up for the serverless platform on our website and stay engaged with us. We have done a lot of thinking around this area, and step functions looks very cool. We have an alternative approach that we may or may not be working on, but I think it's going to speak to your needs. So definitely sign up, serverless.com. Just sign up for the platform beta and stay tuned. And that's it for all my questions. I think that was all 16 of them. So thank you, everybody. Thank you, Diego, for having me. I don't know if you're still there, but
absolutely. Also,
yeah.
I have a question for you. Last question.
Okay.
Are you thinking of integrating AWS code build in the deployment process as well?
Oh, absolutely. We're working on this right now. And again, Amazon just introduced a ton of new Lambda features. It's clearly increased the amount of use cases, the stuff you could do with Lambda. I mean, just the potential developers have to create systems very easily, vastly sophisticated systems via these simple managed functions. It's just greater than ever. It's a very cool time, and we are working hard to integrate with all of those new features that have come out for Lambda, including code build.
Great. So thank you very much, Austen, for being with us today. It's been a privilege to have you present in this webinar. And if anyone has more questions, you can redirect them to cloudacademy.com/community, and then we'll try to do our best to answer all your questions and doubts. Keep an eye on us. So we're going to have many new content in the next few weeks and months. And thank you, Austen.
Thank you, Diego. Super great opportunity. Again, everyone, check out serverless.com if you want to start using the framework. If you want to start contributing, you will be recognized and appreciated. So you've been warned. But we love to have you in the community. Otherwise, go out there and build some fantastic stuff. So thanks, everyone. Thanks, Diego.
Thank you, everyone. Thank you, Austen.